My name is Solveig Arnesen, and I'm CEO here at Vitenparken, and it's my great pleasure to welcome you all here today. I think quite a lot of you are here on Campus Ås for the first time, and that's very good to see you all. And you are all very warmly welcome. So this is the third NOBA symposium. First one was in 2019 when Vitenparken was just only starting to discover what is bioart and what is it to us and how are we going to work with it and what is the bioart scene in Norway. Then in 2021, last year, we had a symposium called Viral Life, very suitable to the situation at that time, and we were asking ourselves like 100 times whether we were able to have a symposium at all. We ended up with a completely digital symposium with only me as the physical person in this room, and all other, both speakers and participants, digitally present. So that's also why it's a great pleasure to see everyone here today for the third NOBA symposium. So Vitenparken, we are a foundation located in the heart of the research community here in Ås, and we call ourselves a lot of different things. Science Center, Experience Center. We work a lot with the same topics that the research community around us is working with. Food, climate change, environmental issues, soil, landscape, a lot of different things. And of course, communicating science, creating science engagement and inspiration is a large part of what we do. But almost since the beginning, I've been working here since 2013, so almost 10 years. And from the beginning, we have always wanted to bring art into how we work with the topics that we deal with. So 2018, we coined the term NOBA, Norwegian BioArt Arena, because we wanted to create a platform, an arena where art and science can meet on equal terms. And we felt that is the right thing to do, and we need to call it something specific to communicate also our emphasis on art, not just something we do as part of all the other things we do, but to kind of create a specific emphasis on the role that art is playing for us. Great, welcome everyone. I told the other people here that you would come with the train to Ås that would be here 10 minutes past, so we are all aware of that, and we are very happy to see you. So there are room on this table, that table here. So come closer and find your spots. I'm just briefly talking about the history of NOBA and the role that NOBA is having here at Vitenparken. So the news maybe for everyone here is that because we have had NOBA as kind of a project to discover and explore what is NOBA going to be for us, and this fall we have decided that NOBA should be a separate department at Vitenparken, and hence it's my pleasure to give the word to head of department, Eli.
Thank you, Solveig. And I'm really happy to see so many people here today for NOBA Symposium 2022. The symposium Humans, Fungi, Rottenness and the Future of Soil kickstarts NOBA's focus on the topic of soil, our relationship to the living soil seen from a more than human perspective that we will be working on for the next 6 years. And today is very much an experiment, and I want you all to see it more as a social gathering. I want you to have fun, and I hope you will leave feeling inspired. We'll have presentations, conversations, a panel discussion, and we'll have activities made by our speakers. And I'm very happy that all our speakers sitting at the top tables here can be here physically today. No one's on Zoom, and I think in post-COVID times, that's really important to meet and do something together. That's the aim of today. So Tracy from Ghana, we have several speakers from Berlin, we have speakers from Bergen, northern Norway, Ås, Nøtterøy. Yeah, amazing. It's a really great group. I'm very much looking forward. And they are curators, they are artists, they are scientists. We have an entrepreneur, we have a designer, we have an artist gardener. And we're going to look at all these perspectives today. I also want to thank Team NOBA for your wonderful work running up to this event. And before I give the stage to our eminent moderator Lena Håkansson, who I met in Svalbard. She's an artist and scientist, and I think she's the perfect person bringing this day together. There are a couple of practical things. There's coffee and tea all day. The cafe is open if you want to buy other things. Lunch is served at 1. The break is a bit short, but you can just relax, eat at your table, don't worry. There's some cake at 3 o'clock. And generally, between each presentation and conversation, there will be a 5-minute break. So there's always room to get some air or whatever you need to do, talk. Good. And I hope you'll have a lovely, inspiring day diving into the soil with us here at Hovedkvarteret. So Lena, the stage is yours.
Thank you so much, Eli, for introducing me, and thank you all for coming here. You're going to see me throughout the program today. I'm going to guide you through the activities. And I've chosen to introduce the participants very briefly. So we're meeting here with art and science on equal terms. And we found it super important to introduce everybody just based on their interest. And if I guess you all read about everybody who's participating and speaking here today in the program. And if you want more information, you can find their bios there. So, it's going to be my honor to introduce the first speakers today. So I'm going to introduce India Mansour and Sybille Neumeyer. And they are here today to introduce us to their really exciting work. So India is working with how microbial communities are shaped by their environment and also how they shape their environment. And Sybille, she's engaged, among other things, in environmental issues and in the relationship between humans and non-humans. So I'm very pleased to hand over the stage to India and Sybille.
Hi everyone, welcome. Thank you, Lena, for the kind introduction, and thank you to NOBA for hosting us today. To begin with, I quickly wanted to share how we both met and why we are standing here together today. As an artist, I work since many years around questions of soil, pollution and soil health, which takes form as participatory workshops, video and installation. This brought me to biodynamic fields in upstate New York, to the storage of contaminated soils in Fukushima, to the mining landscapes around Berlin, and eventually actually to the relic lab of the Freie University in Berlin, where I'm working on a speculative documentary called Terramancy and on artistic tools for examination of soil health. And there I met India and got to know her super exciting, amazing scientific research. And we quickly noticed that we share many questions. And we are discussing these now almost 2 years. So today's presentation does not focus on our individual work, but rather draws from our many conversations. Microbiospheric cycles break down matters. As artists and scientists, we look at soils through different scientific and cultural lenses. Together we move from lab cultures to cultural reflections and back. In times of living on a troubled planet, ever-increasing global anti-ecological disturbances through anthropogenic impacts on our soils, water, life forms, and the multiple interactions between them, we wonder how processes of breakdown not only are challenged to digest xenobiotic encounters, but also how breakdown can detoxify, metabolize, and mobilize cultural matter.
We're still developing our collaboration around ecologies of failure, microbiospheres, and breakdown cycles. So today, we'll take you on a small journey from microbial to planetary scales, explore how these topics invite reflection on breakdown as life-enabling processes, and thus how a scientific experiment may matter as a cultural device.
Being immersed in a troubled, partly failing, or better slowly collapsing ecosphere truly challenges our body-minds, and as well our cultural grounds from which we approach these troubles in multiple ways. All directions seem to lead towards the end of the world, with the question where to go next or where to land.
The blue marble image, a photograph of the planet Earth taken in 1972 by the crew of the Apollo 17 spacecraft, has triggered a collective perspective of the planet as a biosphere. It is also a picture that fueled greater desires and endeavors of space exploration, drawing the imagination towards other planets' surfaces, these becoming screens for projections of escape, hope, and colonization, both for spacefarer sciences and culture, and each of them leaking into the other.
Since the early 20th century, the search for alternate habitats in space and the understanding of the unique life-enabling conditions on Earth has also triggered dreams of controlled, self-sustaining, encapsulated ecosystems, the man-made biospheres. For these undertakings, mostly initiated and executed by Western white men, the success of the biospheres was measured by the endurance of the system and its potential to keep levels of mechanical and technological failure as low as possible. Still, these man-made biospheres, such as Biosphere 2, Mars 500, Eden Project, the Arc of Cape Cod, amongst many others, continuously failed as long-term maintainable closed systems, struggling with off-gassing,
Leaking of air and leaking of waste,
rotting of the membranes,
lack of data accuracy,
toxic compounds buildup,
more leaking,
becoming antibiotic,
and again, more leaking,
but also psychological issues such as boredom,
claustrophobia, the urge of leaking,
power struggles, at times even intentionally facilitated.
or overwhelming tasks of maintenance.
Such failures of anthropocentric biospheres, however, did not diminish man's desire to gain system control via ever more sophisticated technology, and also hardly led to an acknowledgement of the potential non-human allies that make our planet thrive.
Using scientific data as a guide, we will now tell speculative potential histories of two biospheres. A story of persistence. We're zooming out, sending artificial eyes into space and billions of years back in time. Surrounded by dark matter, in vast space, matters of life unfold. Planet Earth is the single largest biosphere that we know. A matter-closed and energy-open system that evolved a living biosphere able to transform the incoming energy sources and develop cycles of metabolizing the internal matter more or less stably over the last 4 billion years or so. Cosmic water fell on its rough surface, carrying the building blocks of DNA that slowly began to seed the ancient ocean with life. The early terrestrials were very different from our current life forms. Maybe they can be best understood by thinking about what we call extremophiles today. A huge spill of nutrients that washed from weathering rocks into the ancient sea eventually triggered the first eutrophication event, allowing some bacteria to thrive, and others not. The so-called Great Oxygenation Event can likewise be regarded as ecological collapse for many of the life forms that had been living before, as well as a collaborative metabolic transformation of the entire biosphere for others. Changing environments trigger collaborations, trigger transformations, trigger modes of persistence. The new Earth that emerged following the massive microbial transformation then became the stage for unprecedented biological diversification and the evolution of more complex forms of life.
A story of possible failure. Recent findings from space sciences show that some 3.7 billion years ago, at about the same time that the primitive life was taking hold in Earth's primordial oceans, the soils of Mars could have been habitable for simple microbes who fed on hydrogen and excreted methane. Thanks to the cosmic meteor showers, Mars had been relatively wet and relatively warm, holding liquid water in the form of rivers, lakes, and maybe oceans on its surface. It had an atmosphere rich in carbon dioxide and hydrogen, gases that interacted to warm the planet. Being farther away from the sun than Earth and therefore naturally cooler, Mars needed those greenhouse gases to maintain a comfortable temperature for life.
But if there were early microbes devouring the hydrogen, their alteration of the atmosphere would have slowed down this warming greenhouse effect and possibly forced them to retreat deeper underground. Eventually, such cooling could have triggered a Martian ice age, making ancient Mars gradually so cold it became inhospitable. In this scenario, these microbes caused their own demise.
Such findings challenge us to rethink the way a biosphere and its planet interact. Still, while one could consider it a quite bleak perspective on the likelihood of biosphere self-destruction, it also highlights how fragile biospheres are. From a vast space with millions of stars, what could it mean to think of our planet as one of a myriad mega biospheres that existed in the interstices between failing and persistence? From such a deep time perspective, our planets are living prototypes of a cosmic experiment, undergoing processes of failure in elapsing time. Other than the prototypes built by man, the galactic bodies tell us stories of different times and scales, of failure or persistence. As far as we know, the Earth has been the only planet that was successful prototyping a stable and sustainable planetary metabolism. If we think of planets as comparative biospheres, how can they help to recalibrate the way we look at ecological collapse and microbial agency and planetary persistence? As Donna Harrow writes,
Of course, from the start, the greatest planetary terraformers and reformers of all have been and still are bacteria and their kin. Also in intra-action of myriad kinds, including with people and their practices, technological and otherwise.
the earlier mentioned man-made biosphere projects, their narratives bring us stories about colonizing outer space and deep sea, or colonizing uninhabitable territory. But as the Earth slowly collapses, it is necessary to return home, zooming down into different scales, and to consider knowing with biospheres as a way of learning how to care. We are landing and digging further, deep down in a vast space, surrounded by dark matter, matters of life unfold. Maria Puig de la Bella Casa so beautifully translates Ursula Le Guin's writing back into earthly concerns. The word for word is soil. Soil as a dark alterity, as she calls it, densely textured, generously pocketed with air and protozoa, filled with necromass and biomass. It is a metabolic body, a metabolic archive, constantly digesting material and chemical information added. A lot of these accumulated biochemical informations is managed, distributed, transformed, and stored by microscopic kin, many of them still unknown and unnamed to man. An ecological program runs our living systems. An earthly living world consisting of myriad of microbial living infrastructures, storage chambers, aqueducts, ventilation systems. The soil teems with life, an interconnectedness that expands far beyond the earthly matter itself. Biogeochemical transformers of our present-day Earth, holding both important lessons and promises for the future.
Following the urge of coming down to earth, scientists today investigate the myriad questions around soil health and soil pollution. A few have asked why biospheres have been used mostly for scientific questions pertaining to off-world possibilities, when they could in fact serve as a powerful scientific tool to better understand our own worlds.
As these quotes show, the scientists reflect that microbial biosphere modeled biogeochemical processes in miniature, and they can help us to better understand our ecosystem ecology. While most closed systems research has been conducted in the name of space travel, Rillig and Antoniowicz argue for the emancipation of biosphere research.
Okay, so coming from space, let's zoom in to a much smaller scale and imagine a soil aggregate. If you imagine a bit of soil that you could hold between your fingers, if we isolate this and imagine it as an ecosystem on its own, could it persist? How would it change, and how would its inhabitants evolve over time? This is what I try to study using microbial biospheres. This is a type of study system that consists of miniature ecosystems that are matter-closed and energy-open. Microbial biospherics allows us to replicate entire ecosystems and gives us the power to ask why in a controlled environment. Seeded with sand, water, and a few soil organisms, I build hundreds of miniature microbial worlds, trying to answer some questions, like, under what kind of initial conditions would these simplified ecosystems be likely to persist or to fail? How can we measure signals of life from closed systems without invading them? What can we see from the outside? And what is the simplest possible ecosystem that is self-sustaining? Some of this research and our shared questions have been leaking into Berlin's biocultural spheres, like in this DIY Hack the Panka event from earlier this year.
While we develop our ideas together, working outside of our bubbles is essential for energy and information exchange, but also for collecting experiences through failures that then co-author our work.
In order for these systems to persist over time, it is necessary for the microorganisms in the system to recycle themselves or each other. Otherwise, the necessary components of life would pile up in a graveyard of microbial corpses, and eventually there would be no resources left. When the organisms in the systems die, these corpses comprise necromass, which, as recent research has uncovered, is extremely important for the storage of carbon in soils. Decomposer organisms produce enzymes to degrade necromass and take up the carbon and nutrients needed for their growth and reproduction. They mineralize excess nutrients and respire CO2, thus providing the photosynthesizers in the system with the resources required for their survival. A simple carbon loop is generated by their interactions, transforming carbon between living, dead, and gaseous forms, and allowing the system to persist. We thought at first that we would frequently observe failure in our simplified systems, that carbon would leak from the loop into unusable pools. We wanted to observe failure, in fact, to better understand it, but after many experiments, life persists even in extremely small, and the simple systems we have built have failed to fail.
The trouble with microbiosphere resistance or persistence reminds us actually, quoting wonderful Lynn Margulis, that Gaia is a tough bitch. Still, as humankind currently Mars forms terror, we don't know how long she will be tough, and also when it will become tough for us. Our biosphere is accumulated with man-made materials like plastic and chemicals. Many of them elude or oppress natural processes of decomposition and recomposition. Further, while industries and modern plantations enrich the ground with microplastic, phenol, antibiotics, pharmaceutical compounds, fertilizers, pesticides, the impact they have on the biosphere is echoed by human impacts on Earth, atmospheric conditions, adding struggle through heat, drought, flooding, all of the unfolding into different temporalities and multiple potential non-futures.
Microbiospheres as a scientific lens on breakdown matters, failure, and persistence can serve as a scientific metaphor for our own biosphere, the Earth, and as an invitation to think with, instead of about, microbial organisms as allies in a multi-species worlding. In a decentralized worldview, which is also increasingly supported by new microbiome research, we are slowly acknowledging more and more that microbes matter, and, being vulnerable, independent co-becomings, that we always need a diversity of others.
While I'm following the experimental processes as a professional non-expert, the design of microbial biospherics experiments allows us to all question how one notices the breakdown of breakdown agents, but also invites us to reflect on how these experiments themselves undergo levels of success, or let's say persistence, and failure, requiring not only constant calibration of how and what can be read from them, but also multiple levels of care, support structures, and maintenance requirements around them, which enable both scientists and me as their guest to work with these matter. And with these more practical questions within and around the lab, a flock of philosophical and cultural concerns arises. How can complex scientific experiments be broken down and reintroduced into the metabolism of social spheres? Where and how do we fail noticing environmental changes, cultural collapse, or the breakdown of life-supporting cycles? Which levels of persistence can diversity in beings, such as artists and scientists, and in their functions as scientists, artists, collaborators, intruders, and friends, enhance? Can vulnerability, in terms of radically embracing our own vulnerable conditions, be cultured as a ground for caring for and valuing diversity?
Can we also become decomposers and break down harmful narratives? Can we metabolize toxic structures while acknowledging our own failures? And how can microbes break down human conceptions of failure?
So as we work on recultivating the scientific experiment into cultural soil for reclaiming breakdown matters, we start with the claim for radical reinterpretation of cultural matter. Stories, narratives, and their smallest components, words, such as breakdown, failure, and vulnerability. As Maria Puig de la Bella Casa writes, reclaiming requires acknowledging poisons in the ground that we inhabit rather than expecting to find an outside alternative, untouched by trouble, a final balance, or definite critique. Reclaiming is here all but about purging and cleaning an ocean. Rather, it involves considering purist ambitions, whether these are moral, political, or effective, as the most poisonous. Thus, we propose reclaiming happens not through erasing trouble, but to invert it, to metabolize it, and to decompose and recompose our thinking. This can only be undertaken as a collaborative, ideally symbiotic experiment, starting with the decomposition of culturally encoded binary divisions between science and culture.
Drawing from our previous projects and research around soils and environmental questions, our work over the last years has been a practice of sharing experience, inspiration, reflections on bodies of evidence, and learning from the other. While we develop our ideas into a collaborative practice, we at times invite the public to join us in our voyage across these scales from microbial to planetary, and to learn and co-think with us. As we are currently co-writing a science fiction story and further developing DIY explorations, the many futures of our microbiosphere collaboration are yet unwritten, but will hopefully be allowing many more sense-making breakdowns.
So to conclude, we also want to thank all these wonderful institutions that are hosting us so generously. The Relic Plant, Fungal and Soil Ecology Lab in Freie University in Berlin, and the Art Laboratory Berlin, and today also NOBA.
Yes, thank you very much.
And to start our discussion, we want to invite you to imagine that you are now microbial agents under high environmental pressure, surrounded by toxic information. So your persistence relies on what is called horizontal gene transfer, like the transfer of genetic information happening between microbes. It's also known as microbial sex. And this is a form of radically exchanging genetic information in order to evolve and to persist. So for the next 4 minutes, as you are actually all experts yourself and holders of observation, of experiences with soil and your biosphere, and of knowledge about the care measures, we invite you to speak with the group on your table and get to know each other and learn from each other and tell each other your ideas, what you're doing, how you connect to these topics that we maybe just raised. And ask yourself as a group also the question, which breakdown measures do you engage in your life and in your practice to protect our biosphere? After that, we will be open for questions and for hearing anything you want to share from the conversation on your table. So enjoy getting to know each other.
I hope that everybody is having some stimulating discussions on biosphere protection measures or microbial perspectives. So we would like to use just the few remaining minutes to ask if anybody would like to share something they've discussed, maybe a microbial perspective or some ideas about biospheres, and we're also happy to answer any questions that you might have.
Yeah, there's one on this table.
So I'm going to come over with a microphone to you, and you can speak in the microphone, so everybody hears.
Hello, I'm Maria, and I have a question for you. I just thought about if you experienced when you established your collaboration as an artist and a scientist, if you experienced that your concepts of failure was different, coming from two different worlds and making experiments and projects together. I imagine, and I have experienced myself as well, that the concepts of when a project is actually failed or successful can be very different coming from different worlds. If that is something that you have experienced in your projects and how you deal with it?
Yeah, definitely. I mean, thank you for this question, Maria. And I think we all have similar but different ideas of what is failure, also based on our experiences and cultural context. For me as an artist, I'm always excited about failures. Whenever something does not work out the way I wanted it, is the way when things get really cool and inspirational. And I think that why when I met India the first time and she told me she's working on something that she intends to fail, like I was immediately in love with that idea. and I think that was sparking our initial conversations that now already take 2 years. But I also realized there are similarities experiencing failures, but then I think it's still like we learn from each other's ideas of what failure actually is, and that helps us also to think through conceptually how we then, as a cultural matter, like trying to decompose it. Yeah. Maybe you want to say something about failure in your project also.
Oh yeah. Well, I think what got me excited about this project at the beginning, one of the things was that I would have the opportunity to study failure, and I thought that that was something interesting. As it turns out, I don't observe it that frequently in my systems after all, but yeah, and I think we also came together over critical concerns about ecological failures, and so that has been a topic for us to both share from these multiple perspectives.
Yeah, and I think to add on that is like it's so inspiring that I guess this very human-made concept of failure, like we keep projecting on environments that are actually capable of also like dealing with like changes, but then the question is not if it's failure or persistence, but also rather our responsibilities of preventing stress for the environments in order to make them thrive, but then also acknowledging that we have harmful impact, you know, so it's like shifting from this failure and collapse narratives that maybe also are like dooming and you know, like not helpful to keep finding alternate ways of being, that then shifting it back to like thinking about stresses and responsibilities is a good way. Yeah.
Do we have time for one more question?
There's two more.
There's two.
Thank you. This is working. Thanks for your talk. First, it was really, really interesting. And I had a question about something that's on the last slide, actually. I'm really intrigued by the concept of terramancy. And if you don't mind, I would love to hear a little bit more about it and whether and how it relates to your science fiction writing, maybe.
Yeah, I mean, like, terramancy is a speculative documentary that I'm doing at the lab now. I came to the lab to explore like visual methods and thinking about soil health, but then like it was striking for me to come to a lab and trying to see soil but not seeing it at all. So what happens in the lab is not the soil as we know it from outside. And then I got interested in these questions of translation and readability. And I started following now for almost 2 years the scientists in their experiments and working on this video that kind of questions ways of calibration of readability and the relationship between medium and message. Yeah. And the sci-fi leaks in there as well, but then it also echoes back in a co-writing we are doing now. Yeah.
Thank you for sharing with us. So I'm interested in the microbial necromass, and if you have any more thoughts regarding life and death, to be a bit wide. Like, how do you approach the what's living, what's dead? Because so much going on in the soil is sort of, it's dormant and it's sleeping and it could be active, but is it alive? Is it dead? What's the function of it when it's alive, when it's dead? Like, if you could elaborate a bit on life and death, actually,
sure.
In between.
Yeah, that's a great question. It was actually a paper recently published called Schrodinger's microbe about this very idea of, is it really dead or alive? What about all of these dormant states that are existing? And it can create some experimental complications that I've been running into, these kind of things that some microbes do when they're under a lot of environmental stress. and they'll slow down their metabolism or their physiology will change. And yeah, I guess necromass, though I think about as something that was previously biomass, but there has been some kind of death process that has led to this matter, and often through that death process has transformed. And I think it's really fascinating in the biospherics context because that recycling of that necromass is yeah, absolutely the basis requirement for those systems to continue persisting over time. And yeah, I'm hoping that that can also give us some hints into what's going on with soil carbon cycling and soil carbon storage.
Yeah. But it's a really good point that you asked this question, because I think death is also like kind of concept that was culturally shaped, and thinking especially about the soil that we for a long time cultivated and were culturing as some dead non-living thing, but just as a resource. And for example, my work at the soil storages in Fukushima was super interesting for me because this living matter was taken from the surface after the contamination and then stored in huge plastic bags and then eventually even buried in the ground, which for me felt like a funeral. And the question of like how do we then hinder it from, you know, continuing living because we closing it into something where, you know, the microbes would die and there would no recycling processes any longer, etc. But then also like thinking of like waste and death, you know, as something that is the end that comes with our thinking is through these projects or these research, I think super interesting, because then thinking in cycles, there is only undead matter, right? And I really like that, yeah.
Thank you so much, India and Sybille. And I think we're going to continue on the topic too about what's alive and what's dead and talk more about this today. Thank you so much.
Thank you.